So, which one to start with? Yes, okay. You definitely need pen and paper. So what I'm doing is I'm showing you the 4 experiments so you can do them yourself tomorrow. Okay. So let's just get this up unpacked. This one.
We should write 4 lab reports about 4 experiments.
Yep. That is right.
How many words?
Oh, we'll talk about that later. Don't worry yet about it. That's okay. Okay, we'll start with the pendulum one, I think. Let me just give you a little bit of background for it. So, during the experiment, do you remember you have a logbook to write down your numbers, your data, the steps that you're doing? Do you do this in chemistry?
No.
You had a logbook?
No.
A logbook to make notes.
We just wrote it on paper.
I'll give you a notebook. That's part of your grade, is filling out the notebook. But I'll talk more about that later. Anyways, the most important thing in the notebook is the data, really, the table with the data. Well, we'll get to, well, no, maybe we will do that. So in this experiment, what you're doing is you're letting the pendulum swing for a particular length. Do you remember the formula for the time? Do you remember? 2 pi root. No one remembers?
L over
L over G, there we go. So what we'll do is we'll swing this 10 times. 10 times. And then we take our time and divide it by 10, and this makes the time for one swing. Yeah? Now we don't want the t. If we look at this formula, you can square it. T squared equals 4 pi squared L over G. Yeah? Now if I rearrange this a little bit, I can get, well, not rearrange it, but I can get T squared equals 4 pi squared over G times L. So I can make a graph here. What should I put on the x-axis? The L. And what should I put on the T squared, thank you. T squared. And then when you plot this for many different lengths will make different times squared, and you'll get a nice straight line, or you hope anyways. But what's the slope of this line? The 4 pi squared over G. Can you see that? Because this is like the y equals mx. So that means you can say G is equal to 4 pi squared over the slope. And this is how you can get the value of g. Okay, so you need to write this down as just basic preparation.
M is the gradient, right?
Huh?
M, is that the gradient?
The m is the gradient, yeah. Yeah? Got that? Yeah? Okay. So, let's go over to recording the data. So you should have a column for the length, and that should be in meters. Okie dokie?
Length, right?
Length in meters. Now, what do you measure when you do this experiment?
The time.
Fine.
The time. The time for what?
One observation.
Well, you're actually measuring the time for 10, and then you divide by 10. So we call that T10. Do you understand? Yeah? Now, in fact, you have to do this twice to make it more accurate. So we'll say A here to mean the first time you do it. And then we'll say, oh, and what's the units here?
Second.
Yeah, seconds. And then we do it again. Yeah? Then what we do is we
Divide.
add them together and divide by 2 to take the middle of them. So that would be T10 in seconds. Then what do we do?
Divide by 10.
Divide by 10. So we'll call that
T1.
T1 in seconds. And then finally, what we really care about is not the T, but the T squared. So we just square this last number, T squared, seconds squared. So we put this one goes on the x-axis, and this one goes on the y-axis. My table is ugly, I know, but I hope at least you understand what I'm doing. Is it okay? Yeah. Now, you change the length. So you will have a meter stick. You know a meter stick? It's 1 meter long. I forgot to bring it. And you should change the distances by 10 centimeters. So you could start at 1 meter, 0.9, 0.8, 0.7, 0.6, and so on, down to 0.1. Now I forgot my meter stick. So all I'll do as an example to show you is I'll start with 0.10 meters as an example, because I have this one. Also, I think it's good if you put this here to just make it a little bit more stable. Okay. Right, so this is the clamp. Let's measure out 10 centimeters. Okay, this is we'll just do 15.5. Actually, I forgot there's two extra columns on the table which we haven't talked about yet. I'll just put them down the end. The column should really be here, but should really be like here.
What is it?
The ones I forgot. The ones I forgot is this one, delta L in meters and delta T10. Yeah, I forgot to put these in because I haven't talked about them yet. But the delta L, that's the uncertainty in your measurement. Maybe you did this in chemistry. It's like the error. Do you know what I mean? The uncertainty?
Delta T10.
Yeah, in seconds. Yeah? Now, when you measure with the ruler, how accurate do you think you are? So what do you think your error could be?
0.3.
Say half a centimeter at most is your error. So that would be 0.005. Now when you are measuring your time, you can know your error because look, you have to measure it twice. Yeah? So your error would be, if you want to think about it like this, TB minus TA over 2. That's how big of a difference there is between the two measurements of time. The TA and the TB should be the same, right? Why should they be the same? Well, it's 10 swings, yeah, and the length is the same. So the fact that they're different means there was an error. So actually this is how you can calculate the error in the time. But the error for the meter stick, you just have to say it's 0.005. Or, there's another way you can say it if you want. Can I go back to the left? I'll just make it here. Another way you can do it is like this. Here's the L min, L max, delta L. So when you measure 0.15, you think it could be as big as 0.155, or maybe it was as small as 0.145. So that makes the error 0.005. This is the error. It's like how much you don't know, how wrong you could be. Okay, anyways, we say 15.5. Okay, so when you do this, have you got everybody take out their watch on their phone?
That's an example, right?
Well, there's just two ways to show the uncertainty for the length.
What is it like minimum length?
Length minimum is the smallest you think it was, and length maximum the maximum. Because you realize when you measure, of course, it can't be perfect. So there's kind of a minimum, maximum you think it could have been. Okay? Yeah. So, if you got your stopwatch, you can count me down. Now, by the way, before I start, look, this counts as 1. It's all the way over and back. That's 1. Okay. So I want you to say then, when you're ready, you say to me, 3, 2, 1, go. When you're ready. So you tell me.
3, go.
1, 2, 3, 4, 5, 6, 7, 8, 9. Stop.
9.2.
Nine.
What did you get?
7 seconds.
Oh my
I'm very
goodness.
close to 8.
Alright, I'll say 3, 2, 1, go, and you'll all record it, okay? 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop.
8.8.
8.7.
Good, 8.7,
8.8.
8.8,
8.38.
8.38, okay.
9.
9, okay, great. So it sounds like the uncertainty was maybe about half a second, which is not so bad because that's actually for 10 swings. So for one swing, it would be 0.05 seconds. Half a second divided by 10. That's pretty good. Okay? So that would be like one data point. Now you should try and go 10, 20, 30, but of course it's difficult to get 10, 20, 30. So it's okay if you have like, 15 and a half or 19, 31, these are okay. Like here, this will be not too much for my ruler. This would be 23 and a half. So that's okay. Make sure you measure from the center to where it's turning.
The center of the ball.
Yeah. That's probably a better way. Anyways, okay, so that's the first one. Who are you talking to?
Chris.
Okay, can I put this in a way?
Yeah.
So this is a very simple one. This isn't the first one you're going to do. This is experiment number, I don't remember. Experiment number 3, actually. Okay. Right, so that was pretty easy, I think. Okay. Let me just put this back in the box. Which one we do next? Electricity, I think? Or maybe we'll do Newton or Snell.
Lasers.
Let's do the laser one next.
Oh, we don't have wood.
Ah, but you said you'll get me some. Didn't you?
No.
Yeah, I'll have to get water. I'll do that one later. Let's do the electricity one next. So I should draw the circuit for the electricity one. Okay, so this is the circuit for the electricity one. You have your battery. Okay, you have your ammeter. This measures the current. Then you have your voltmeter, variable resistor. Then you have your resistor OR. And then you have your voltmeter here. Okay. Can I go on? Lots of writing for my little picture. Continue? The two at the back look like they're still writing. What's taking so long? Continue? Yeah. So let's say this cell is E, and let's use Kirchhoff. So let's say the current here is I. So I have E, and then what happens when I hit this one? It'd be minus V, because I know the voltage, it says V. And then when I hit this one, it would be let's call this, I don't know, small or some other letter, or x or something, minus I or x equals 0. So this is constant. So if I just rearrange this a little bit, v equals e minus I or x. So what happens if I make the or x bigger? What happens to the v here?
Smaller.
Smaller. So in other words, by changing this, I can change this. And this will change also. So I have a way to change the v, and the I will change also. Using your law, v equals I or if you want, I equals 1 over or v. I'll make a graph. On this axis, I'll put v, and on this axis, I'll put I. What will the slope represent? The slope will be 1 over or. So then, how can I get the or, Amanda? Yeah, it'd be 1 over the slope. Oops, sorry, it's cut off the bottom. There. Or if you want, it's 1 over the m. So we have our line, and this has a slope m. Okay. You got that? Yeah? So you can do an experiment like this to find the resistance or. So let me set it up for you. Right. So firstly, we'll start with the battery. There's our battery. Okay. Next, we need our switch. So there's our switch. And then we have these little magnet cables. Okay, so we'll just stick these in here. Which way do I want? Right. So what I'll do is I'll just make. Well, I won't put the voltmeter or the ammeter in just yet. I'll just put in the resistor. So here's our resistor here. And then I've got more cables here to pump. Right, so actually I do need another cable for my magnet. So stick one on there. Stick one on there. Copy. Right, okay. So I haven't done anything interesting yet. All I've done is made the switch, the battery is there, the power cell, and then the resistor. But I don't have any ammeter, voltmeter, or variable resistor. They're not included yet. So it's just a simple battery, resistor, and then the switch. Okay. So now we'll start putting in maybe a voltmeter next. So you have this here is called a multimeter. And what's nice about a multimeter is you can use it to measure many things by just changing the dial. So you can set it to voltage. So the voltage here is quite small. It's, you know, like, I don't know, like 1-2 volts. So you want to see if there's any setting for small voltages. I can see there's a 2 volt setting here. So I think 2 volts would be good. Yeah. There's 2 volt setting here. Right, so take out the cables for this. So there's 3 holes here. Okay. Always, it always uses the middle one. And then, if you want to measure volts, ohms, milliamps, or temperature, you can use this one. But then if you want to measure large amps, like example 10 amps, then you use this one. Okay? Now I don't know what the current is. I don't know if it will be a big one or a small one. But anyway, it doesn't matter because right now I'm making a voltmeter, so I'll put in a voltage one here. Okay. So our voltmeter, you can see, is around this resistor here. So I'll put it around that. Steady. That screensaver, come on.
Yeah.
What screensaver did I get today?
Actually, no, it wasn't, it's not a screensaver, I think it's just
Yeah. Okay. Right, so let's check that this works. So let me set it to 2 volts. And close the switch. Yeah, actually I should turn this so you can see it. So there's the voltage. It's jumping a lot. We'll talk about that in a moment. Okay. So next, let me put in the ammeter. So the ammeter, we can put it beside the battery. So what I'll do is I'll put it, I'll put it in here. So let's put in this one. Let's try the 10 amp one instead of the 10 amps. Okay. No, I don't know why, but these two don't stick together. So maybe I'll just maybe cheated it. No, I'll have to get another. I have to get another clanky one out. Okay. So let's just stick this one at the end here. And let's stick this one at the end here. Oops. Right. And let's close the switch. Sorry, let me put this up here. Okay, so this is the ammeter now. That's okay. So you see here we have 0.18 amps, and here we have 0.19 something amps. Yeah. Sorry, volts. Yeah. So there's only one thing missing on my circuit. Let me open the switch. What am I still missing? What have I not included yet? Which is this. Oh, because it's so powerful and expensive. Now, I know it just looks like a piece of wood with some wire on it, but that's what it is actually. This is, hey, come in. We made it.
No.
You'll need this knot here. This here is nickel chrome wire, and what you do is by changing the length, you change the resistance. Because you remember the formula, resistance equals rho L over A. Do you remember this formula? What do you mean no? This one. Resistance is rho L over A. No, resistivity. Remember? Right. So anyway, this here is how you can change the resistance. So we'll put it, doesn't really matter, maybe we'll put it, maybe we'll put it somewhere. Maybe I'll put it after the ammeter, before the switch maybe. So I'll clamp this here at this end. Then I need another clamp. So you can see why it's important to take the time with this one, because there's lots of cables. You don't want to get them mixed up. Okay, so now we have it. Let's close the switch. So I have my I and I have my V. I can then open the switch, move this a little bit, changes the resistance, which will change the voltage and the current. So if I close it again, now I get a different value and a different value here. And if I put it, say, in the middle, and close it, 0.06 amps and 0.074 amps. Okay? Yeah? Please remember to turn the switch off. So let me show you how to write that in your table. So firstly, you have your voltage, V min, and then V max. Oh, sorry, this should be in what unit? Volts. And then V max in volts. And then V in volts. And then I min in amps. I max in amps. And then I in amps. So let me explain what I mean by min and max. Yeah? Can I go to the side?
Yeah.
Yep. Okay, so let's imagine when you're looking at your voltmeter, sometimes it says 0.015, but sometimes it says, when you look at it, 0.017. So it's kind of moving a little bit. So what value do you use? Well, what you do is you use the smallest value, the biggest value, and then the value you use for your graph is what? What do you think? Yeah, the value you use for your graph would be V min plus V max divided by 2. So what's the smallest value here? It's not actually. The smallest is 0.0145, because you don't know, maybe this is actually 145 and it's rounded up, because this is only 3 decimal places. What's the biggest this could be here?
0.015.
555.
Yeah, well, it's really more like 4999, you know. So we'll just say 5, although it's a little bit less than that. That's the biggest it could be. So that would be 0.0175. And then finally, the uncertainty. That would be the biggest value minus the smallest value divided by 2. That's how much it can change by. Yeah? Is that okay? And then you do the same for the I as well. Okay. Any questions about this one? No? What goes on the x-axis? Did you write that down?
Yeah.
The b and then the I, and you want the slope then. Okay. Let me just pack this one up now. Right. No problem. Some students, you can see they mark the distance with a pencil so that they can help move them along. You don't have to do that, but it's good if you want to do that. Okay. Right, next. Now, so that's the electricity one. Okay. Next. Maybe we'll do the units one next. What do you think? Or, okay. Do units one next. We'll do. We'll do them in a few minutes. Because what I want to do actually is I want to print out something for you to have. Yeah. I'll take a break for a few minutes. I just want to print something for you, okay? Tomorrow, because there's only 1, 2, 3, 4, 5 of you, and there's 4 experiments, you'll each do an experiment by yourself, no partners. But that means there'll be one person at one time not doing an experiment. So just so you know for tomorrow actually, what will happen is there'll be 1, 2, 3, 4, 5 tables. And this table has no experiment on it. And then 1, 2, 3, 4 like this. So we'll have, for example, Hareen here, Amanda here, Grace here, Sophie here, and then Andy here. And then I'll give you, how much time do we have? 3 hours tomorrow, I think, is it? On the timetable? Is it 3 hours?
We didn't get it.
I didn't get it. Okay. Well, I think tomorrow it's 3 hours, okay? So if it's 3 hours divided by 5, what's that now? 36 minutes, is it? I think so. Isn't it?
Maybe.
Yeah, 36 minutes. Anyway, that's how much time you have for each. No, it's not. Because 60 minutes times 5, you know, is 5 hours.
Wait, you like 5, right?
Yeah. Okay, great, thank you. So what will happen is, every 36 minutes, what will happen is, you'll move to the next table. So it goes around like this. Okay? So it means, at least once, everybody will do one of the experiments, but for 36 minutes, you'll be at a table, not doing anything. But you can use that time to write in your lab book. Okay, which is what I want to print out now for you. I think 36 minutes is enough time. Like, it should only take, I think, 30 minutes for each experiment, right? As you can see, I did 2 of them, or I explained 2 of them. Yeah, 36 minutes I think is enough time. You think so too? If you run out of time, we'll worry about that tomorrow, okay? But let me just print some stuff out for you. You can take a break for a few minutes.